Astronomers think they have identified a lava world so dramatic that it might boast a thin regional atmosphere of vaporized rock, where it is closest to its star. Today we will discuss with you about the exoplanet K2141b, home to lava and supersonic winds. Welcome back to Signature's Life, and you're watching Signature's Science. The exoplanet K2141b and was originally discovered in 2017. The world is about half again as big as Earth but orbits so close to its star, which is one class smaller than our own, that it completes several loops each Earth day with same surface permanently facing the star. Now astronomers predict those factors mean that 2/3 of the surface of K2141b is permanently sunlit. So much so that not only is part of the world covered in a lava ocean, but some of that rock may even evaporate away into the atmosphere. It is a hot lava world on one side but extremely cold on the other. K2141b is one of two planets in a star system about 202 light years from our solar system in the direction of Aquarius, the water bearer, a constellation seen from all parts of the world on November evenings. K2141b was a tempting target because it's been studied by both the K2 mission of NASA's Kepler Space Telescope and by the agency's Space Telescope. The planet's density is about that of Earth's, so the crust can be modeled as pure silica as a reasonably simplified representation. Then the scientists figured out what the surface might look like. K2141b is only about 11 by 2 times the radius of Earth, but is a very alien world. Its surface, atmosphere, and ocean are all composed of rock, specifically sodium, silicon monoxide, and silicon dioxide. At the edges of the atmosphere, where temperatures drop, the gaseous rock would cool enough to fall back to the surface as precipitation. If the atmosphere is dominated by silica or silicon monoxide, that precipitation would mostly fall into the magma ocean. But if the atmosphere is predominantly sodium, the planet would look even weirder, with solid sodium oozing back towards the ocean like glaciers here on Earth. The planet is tightly locked to its star, meaning that the same side is always facing the star, just like one side of the moon always faces Earth. About 2/3 of K2141b is in perpetual daylight, something we never experience on our own world. Being tidally locked this way means that there are drastic temperature differences between the day and night sides of K2141b. On the side facing away from the star, it is bitterly cold, estimated to be below -330 degrees Fahrenheit, otherwise -200 degrees Celsius. But on the star-facing side, the temperature is estimated to be a scorching 5,700 degrees Fahrenheit, otherwise 3,000 degrees Celsius. The rock vapor that is created on the day side of the planet also acts as precipitation. The cycle is basically similar to what happens on Earth, but with no water involved. The mineral vapor behaves like earthly precipitation. The supersonic winds carry it to the night side of the planet, where it rains down to the surface. The currents in the magma ocean with the precipitated minerals flow back to the hot day side of the planet, where the rock minerals evaporate again. It's a regular cycle, but not as stable as on Earth. Since the flow of magma ocean back to the hot side is slow, the scientists say that the mineral composition will gradually change over time, affecting both the surface and atmosphere of K2141b. Lava worlds like K2141b are unknown in our solar system. Even Mercury isn't close enough to the Sun to have magma oceans on its surface. On Earth and Jupiter's moon, Io, and maybe Venus, the lava flows from volcanoes can give an idea of what it's like, but it's still not the same as having much of, or most of, a planet's entire surface literally melted to create magma oceans. It's a world that is scorching hot on one side and freezing on the other, with a magma ocean about 62 miles, otherwise 100 kilometers deep. Rain composed of rock that evaporates and then precipitates in a regular cycle similar to the water cycle on Earth, and supersonic winds over 3,100 miles per hour, otherwise 5,000 kilometers per hour. Scientists call K2141b an especially good target for atmospheric observations. These new findings say to us that there are still so many things out there which needs to be found, and still they are living mysteries.